Given, positive integer array nums and integer threshold. Choose a positive integer divisor d, return, the smallest positive divisor d that satisfies the sum bound. Example 1, nums 1, 2, 5, 9 and threshold 6. Try divisor 5. Seal of 1 over 5 is 1, 2 over 5 is 1, 5 over 5 is 1, 9 over 5 is 2. The sum is 5, which is less than or equal to 6, and no smaller positive divisor works, so output 5. We sum integer ceilings of each value over d using open paren number plus d minus 1 close paren divided by d. Each term is at least 1, so the sum grows if d shrinks. Call it fits when that sum is less than or equal to the threshold. Bigger d never raises the sum, so feasibility is monotone. The dot marks your current d on the line, the number below is the full seal sum for that d, and it changes when you slide the dot to another d. We only need d from 1 up to the max element in the array. Binary search with inclusive ends. If the midpoint fits, remember it and move high left to try a smaller d, otherwise move low right. When low passes high, the last saved fit is the smallest divisor. Trying every d in order repeats the full seal sum check for each new d. Bisection on d needs far fewer candidates because each step shrinks the remaining range. We start with low equal to 1 and high equal to the largest value in nums. The answer never needs a divisor larger than that, since a bigger d only lowers or keeps each ceiling term. Each step sets mid to low plus open paren high minus low close paren, integer divided by 2. That form avoids overflowing when low and high are enormous. For this mid, walk nums, add open paren number plus mid minus 1 close paren divided by mid for each element, the integer ceiling, and accumulate the total. If the total is less than or equal to the threshold, mid works, so try smaller divisors by setting high to mid. If the total is greater, mid is too weak as a divisor, so set low to mid plus 1. Repeat while low is still below high, every step shrinks the interval about in half. When low and high meet, that value is the smallest divisor that satisfies the bound. Time is order n log m, where n is the length of nums and m is the maximum element, because each guess scans the whole array once to sum the integer ceilings, and binary search halves the divisor range about log m times. Space is order 1, only a few integers for bounds, midpoint, and the running sum. Pseudocode on screen, binary search the divisor d between 1 and the maximum array value. Each step tests the middle d by summing the integer ceiling of every element over d and comparing that total to the threshold, then shrinks the window with high equals mid or low equals mid plus 1 until low meets high.